Welcome back, students. Welcome to the course Natural Language Processing. My name is Priyanka Gupta. I am working as Assistant Professor in Department of Computer Science and Engineering in Data Science Department of Institute of Aeronautical Engineering, Hyderabad. I am going to today discuss about information extraction. So, if you are having any paragraph, if you are having any document, so from there, how we can extract the different sentences and how we can extract the different words that we have seen in the last class. But here, how the different information will be just classified according to the different other rules that we will discuss today. So I am going to discuss about information extraction part. So those are nothing but the part of a speech tagging, named entity recognition and relation extraction. So there are more, but we are just introducing about 3. And I will also tell about how does information extraction work actually in the larger amount of document or larger amount of data set. So basically the information extraction is in NLP, that is natural language processing, is the process of automatically extracting the structured information from the unstructured text data. So hence, we are having the large amount of data anywhere. So if any data set also, if we will extract, so how to extract the different information from there? That can be unstructured also sometimes. So how to just extract the useful information in a structured way? So that is called as information extraction. So information extraction is a subfield of natural language processing that is going to evolve the automated identification and extraction of structured information from the unstructured or semi-structured data or text data, right? So let's talk about the goal of this. So the goal of this information extraction is to transform the unstructured data into structured text data that can be easily analyzed, searched and visualized. So that is a need of to just extract the different information from the text data, right? So after the extraction of this information as a structured data, we can process that, we can search the different patterns what we need, and we also can visualize those in the form of different charts and graphs. So that is a need of information extraction in NLP. So basically, we can say the 2.5 Clintian bytes of data, that is 10 to the power 18 billion data is there that is generated every day, and ranging from that can be from that can be generated from the social media, that can be generated from the scientific literature. So there are many sources of that, from there it can be produced. So many organizations in that case that going to rely on information extraction part, so that they can apply those techniques and use the natural language processing algorithm to automate the manual task, and they can extract the different information out of that. So that is a basic goal of many organizations. Now, information extraction actually involves the identifying the specific entities that can be called as a relationship, unnamed entities like people, organization, if there is dates, if there are location. So these are the we can say entities and the information extract that can recognize, and that is in the form of pattern, and going to convert those into the structured format that can be analyzed after that and used for the various application for our need. So that is a basic use of information extraction. Whenever it will be applied, it is going to just extract the different specific entities, like it can be the relationship, it can be the events of interest, it can be the named entities like people, organization, name, date, location, likewise that. So these type of named entity will be extracted, and then it will be just that is going to be just changed in the format of structured data, and then we can use that type of data in for our various principles, right? Next, for example, if I will take example from the cricket news article, so let's see, that is one sentence, one paragraph has been given, and that is Indian captain Virat Kohli was dismissed cheaply for just two in Wellington, like on Friday by dependent Kelly Jamieson, extending a rare lull in batsman stellar career. Throughout the ongoing New Zealand tour, Kohli has managed to score just a single 50 across 8 innings in all 3 international formats. So this a sentence has been given from the cricket news article. We can extract the following information from this text in the form of information. So that can be, we can extract the country names from there, so that it has been written India here, India over here. So in the country name has been used here. Second is captain. So captain is here. It is indicating to Virat Kohli. So that is the other named entity, and that is going to just we can say point to Virat Kohli. Next is batsman. So batsmen are Virat Kohli. He about him only this article has been written. And second is how many runs he has completed, to 2 runs. So 2 runs for this particular one event they are asking for, they are talking about. And then second is bowler. So bowler name is Kelly Jamieson. So his name. So likewise, that match venue Wellington, match series New Zealand, series highlight, single 50, 8 innings, 3 format. So this is all the information from this particular paragraph that is about the Virat Kohli cricket career. So likewise, that we need to extract the different information, and that is going to be just extracted from the different machine learning algorithm along with the NLP algorithm. Likewise this, so that will be called as a named entity recognition. Different other formats also are there. So here we have seen the different entities that in the name that is in the form of named entity. Next, creating such structured data using the information extraction technique will not only help us to analyzing the document better, but also that is going to help us to understand the hidden relationship in the text. So as we have seen in this slide, so what he was asking about the Virat Kohli career, and in the next sentence it was just indicating about him using he word. So likewise, that it is going to give the relationship also between the different text in the context. So information extraction is a challenging task whenever the machine is going to be do that. So we need to just understand that how it will be worked. That is going to require the use of various techniques. So the techniques are nothing but in the natural language processing, some of the different methods we need to apply for that. So first is named entity recognition, that is called as a NER. Second can be as a regular expression, in that we need to just write the different patterns to just search for that. Like if we need to identify the different dates, different year formats. So likewise this, we need to just extract those patterns with the help of regular expression. And next can be the text matching among theirs. So likewise, these are some techniques we can apply to just extract the information from the document. There is a wide range of applications involved. So including we can use this in the search engines, chatbots, recommendation system, fraud detection, among others, making it a vital tool in the field of natural language processing. So there are many range of applications is there that is involved with the help of this information extraction. So some application I will name that that is search engine, where we can apply this information extraction techniques. Chatbots, whenever we the company we can say many productions, they need to just have the chatbots in the form of to give the customer some platform to just talk about the customer care. They need to just check about the different products, or they need to just solve their queries. So they need chatbots. Recommendation system. So whenever we need to use the different websites and applications that is going to recommend specific products whatever we have used in the past. So in the basis of the our historical data, it is going to give some recommendation. And fraud detection, so wherever if there is any fraud there in the some transaction, likewise in the financial system, that is going to give some message according to that. And these are going to be help to extract the useful information, some specific information out of that in these different applications. So that is going to make the natural language processing a vital tool to just use widely for the different purposes. So that is a basic use of this information extraction widely. So likewise that we are going to involve different applications with the help of information extraction techniques. Next, if I would like to tell about these different techniques, what are those? So I have named that is first is named entity recognitions. So that is important to just understand about that. Why? Because that is going to extract the different entities from the text, which can be referred to with a people name, with a proper people name, organization name, date, likewise this some specific entity which is going to refer. So any word, we can say group of word, that is going to make that as an entity that is going to consistently refer to the same item, that is considered as a one entity. That is a called basically as a that is a one entity in that particular sentence or paragraph. So whenever the group of words, a word that is going to be consistently refer to the same item in the next sentence, whole document, that is called as an entity. A two-step approach lies in the heart of this named entity recognition. Those are detect a named entity, and then we need to just categorize, the algorithm is need to just categorize these entities as per the different formats. So that is a use of this named entity recognition. That named entity recognition is basically appropriate for any scenario wherever a high level overview of a significant amount of text is required. So whenever we are having a large amount of data set, large amount of data that is going to be just processed as a text processing, and we need to just extract the useful information in the form of this named entities, in the form of tags. So we are using this natural named entity recognition. So that will be, in that scenario, that will be very, very useful and appropriate to use that whenever we need the significant amount of text to be extracted. Then we can also categorize the text based on their relevancy and according to the similarity with this named entity recognition. And then we can comprehend the subject or topic. So suppose that is also a use of this named entity recognition. We can fastly recognize the text based on the different scenarios, based on the relevancy, based on the similarity with the named entity recognition. That is as an entity we need to recognize the machine learning algorithm or natural language processing algorithm need to just recognize, and then it is going to just comprehend that particular entity to the particular subject, a particular topic that can be related to that. That is going to point that. So let's take an example. In this example, Barack Obama is the name of person and the United States of America is a country. So let's see this sentence. The sentence is Barack Obama was the president of the United States of America. So here Barack Obama is the name is going to be indicate that it is a person's name. That is a person's name. That is a person entity, right? And here the United States of America, that is going to be point this as a, that is a country. That is a country. So that is nothing but the named entity recognition tag. So by using this type of tags, that is going to be just classify those named entity as a we can say particular tags, that is going to be just classified in a particular tag. Second is relation extraction. So relation extraction is going to extract the different relation between the different entities in the particular sentence, particular paragraph, or particular document. So whenever one sentence has to be used, and in that particular paragraph and particular sentence, it is going to just show us the different relationship between the two different sentences, and that is actually entity, that is a named entity, then we can call that as it is a relation extraction part of that. So let's take a sentence, and then we will understand. So here take a sentence: Barack Obama was the president of the United States of America. So some slighter change in that particular earlier sentence. So he was the president of the United States of America. So means here the Barack Obama is going to be related to the United States of America. He was the president, as a president. So it is going to some give the relationship that he was the president, that he is going to give the more pressure, more we can say pause on the president word. So that is going to just show the president was the person Barack Obama, who was in the United States of America sometime. So that is how the different relations also can be extracted in the form of we can say named entity. So that is the second part of this we can say information extraction. So these two, and that is third part, that is a part of speech tagging. So in part of speech tagging, that is also called as a certain part of speech. So certain part of speech in the from the text or from the speech we can say audio file, that can be just tagged, just that can be made as a token. So part of speech tagging is a common natural language processing procedure, a method that involves the classifying the words in a text. So that is going to classify a word in a text in accordance to the with a certain part of speech. That will be based on the word's definition and the context it has been used for that particular sentence or paragraph or document. Means if suppose we need to extract some particular word, some specific word from a sentence, that is going to be just have some grammatical we can say reference out of that, that is going to give the some grammatical definition, and that is also going to give that particular word in the context. If some same word has been used again in that particular other sentence, that is going to be referred that also. Means for what context that particular word has been used in the different sentences. So the sense of that particular sentence can be different for that particular word. That is needed to be identified, that can be classified in the terms of grammatical definition and the context of that. So that is called as a part of speech tagging, that is going to classify words according to the certain part of speech based on the word definition and the context of the definition, how it has been used for that particular sentence or different sentences for the document. Now if I will talk about the default tagging, so the default tagging also occur out of this part of tagging. So the default tagging is the first phase in this part of speech tagging process. So first phase is the part of the default tagging. It is done with the help of default tagger class. So the default tagger class will be just used in the different libraries, but in the earlier classes we used to talk about NLTK library, that is used in the for the different natural language processing processes and tasks. So that we have used, and we will also use some other libraries, but I will talk about here only about the NLTK library. So in the NLTK library, that is natural language processing toolkit library, in that we are having the default tagger to just identify the different part of speech tags. So that will be the first part, that is called as the default tagging. Next, the single parameter of this default tagger class will be the tag. So whenever it will be tagged default in the default condition, that is making a tag out of that, a word as a tag. And single noun is designated by the abbreviation NN. So whenever we will do that, there are particular definition, grammatical definition of the particular tags of word. So first can be just identified as a, if whenever we are using the single noun word somewhere, so whenever we are applying this part of speech tagging method on that, so that is going to identify a single noun that is going to identify, and that is going to give in the form of NN, capital NN. So that is the single noun word can be as a tag in the part of speech tagging. Next, sometimes we can say extracting the information can purely based on the POS tags is not enough. So we have seen the named entity recognition were there, relation extraction were there, and some other techniques are also there to just extract the information, but they are not enough to do that. So suppose if I wanted to extract the subject and the object from a sentence, I cannot do that based on their POS tagging, part of speech tagging. So for that, I need to look at the how these words are related to each other. In that condition, I am going to just see what is the relationship between the different words to each other, how they are just connected with each other. So these type of we can say words is called as a dependency. These type of words will called as a dependency, and that is going to make a directed graph. Whenever we need to just deploy that, whenever we need to just visualize those to just understand the we can say grammar of that, we need to understand the definition and context of that. So these dependency will just depicted by some directed graph and known as a dependency graph. So we will see in the next slides what is dependency graph, how it looks like. So it is going to actually represent the relationship between the different words of a sentence. So that is a use of this particular dependency graph, and that is not actual will be used for the POS tags, relation extraction, information extraction, named entities. So that is something else that is going to just deploy the what relationship each word is having to each other. So that will be just depicted by the help of dependency graph. So for example, in two sentences, see the part of speech tags that is going to display the word dependency in each other in the grammatical manner. So let's see a sentence here. That is, one sentence is I like to play football. That is the first sentence. And second sentence is I hated it in my childhood. So that is a second sentence, right? Now, the first sentence, I like to play football. Here, that the first, the I is going to be just indicate that is a pronoun actually. Like is nothing but the verb. These are parts of text. Third is to is the part. That is a part to just connect those two words. And the play word is nothing but the verb. Next is football. Football is indicating that is a noun, right? So now how they are just dependent to each other, how they are just having the dependency. So like is going to be dependent on I, that is the subject, and here this like is going to be dependent on play, that is a complementary, and that to and play, that is going to be connected the like word to each other, but they are dependent to each other, that they are auxiliary word. And also here the play is going to be dependent football, that is a object, right? So like that, this dependency object dependency graph will work to identify the different relationship, right? Let's see the second example, that is a sentence, I hated it in my childhood though. So the first word I is going to be just indicate that is a pronoun. Hated means it is verb. The hate word has been used in the form of verb. It is a pronoun again. In is the adjective. my is the adjective, childhood is noun, and the is this adjective. So now here also same condition. The hated is going to be dependent on I, hated is going to be dependent on it, in, and the, and again the in is going to be dependent on childhood, and my and childhood, that is going to be just connected with each other with this two words. So these are how the knowledge graph will be depicting the different relationship between each other, depending on the different grammatical relationship in the context of the different sentences. So that is how we can just understand the different dependency to each other. So for example, we have seen in these two verbs, two sentences, though dependencies were there. So here the default tagging is the first page in the part of speech tagging, right? So that can be just identify whenever we are applying the default tagger class. Default tagger class, whenever we need to write that in the Python programming language, just calling the different we can say a different library, that is NLTK we are applying here, that we need to import that and we need to just download that, and we can just extract the different default tags out of that. Here in that particular dependency graph, we have seen each word is a node. Each word is a node in the dependency graph. So each word will be called as a one node, and the relationship between these words will be just denoted by the ages. That will be denoted by the ages that we have seen in the graph. So for example, let's take another example, that sentence is the child love ice cream, the children love cream biscuits, right? So for example, here the is a determiner here. So the is a determiner. So that will be write as a determiner. Here children is the subject of the sentence. So children is the subject, sub, and biscuit is the object. Here biscuit is the object, right? And cream is a compound word. Cream is the compound word that is going to just use to just complete we can say make more beautiful the word biscuit with the help of this cream biscuit. So that is going to help with this compound word to make it beautiful, and then that is going to give the more information about the object biscuit actually. So that is how we can identify, and love is again that is verb. So likewise that these all will be dependent to each other with the grammatical aspect in the grammatical form, to just making the relationship between each next word to each other for one sentence. In the other sentence also, if it is referring that particular word, so again it is going to make some other relationship, like we have seen in the Barack Obama sentence. So 2 times the same sentence has been used, but that was giving the same relationship in the next we can say sentence, and in the first sentence it was just indicating the different objects and entities. So for that I need to look at how these words are related to each other. These are called as a dependency. So they are dependent to each other. Dependency is there. Dependent words are there. So whenever we need to just show in the dependency graph as an arrow, in the form of arrow, that is carry a lot of significance here. So first significance is the arrowhead going to point the word that are dependent on the word pointed by the origin of the arrow. So that is how the arrowhead is going to point the origin of that particular word. That again the former is referred to as the child node, means this going to need refer as a child node for the letter. For example, here in that particular example we have seen the children loves this cream biscuit. So there the children is going to make children was referring to the this verb that was love to eat cream biscuit. So children is the child node of love. That is a verb used here in this sentence. Now the word which has no incoming arrow is called as the root node to the sentence. So whenever there is no root, there is no upcoming arrow is coming to any word, that is called as a root word for that particular sentence. So this is how the arrow is just indicating the different significance for the each dependency of the particular, we can say that particular arrow itself. Whenever head is pointing the dependency, the tail is pointing the child node, that is a child node, that is the referring formal. And then if there is no arrow incoming arrow is coming, then it is called as a root word. So that is how we can just identify. Now using POS tags and dependency tags, we can look the relationship between the different entities in the sentence. But that is how we can just extract the relationship between the different entities from the sentence or sentence. So for example, in the sentence, if I will take another sentence, the cat perches on the window sill. That is one sentence we have taken. We have the subject cat. So here the cat is going to be identified as a subject. The object is window sill, that is identified as an object related to preposition on. So by the help of this preposition on, we are going to just, that is that one subject is going to be just make a relationship between the next object. So likewise that the different dependency will work. So we can look for the such relationship and much more to extract the meaningful information from our text data. So that is how we can make sure we can identify the different information and tags, and how they are going to just make the different dependencies, different relationships, different we can say context, we can different grammatical aspect out of that particular sentence. Now let's talk about how does this information extraction work. So I will talk about the coding part of that, how we can write the different code for that, how we can extract the different information. Whereas in the sentence, if I'll take a sentence, you have the right to say whatever you want. So right is here treated as a noun, because from here, the right is just indicating the person what he wants to do. This goes to show that the part of speech tagging of a word carries a lot of significance when it comes to understand the meaning of a sentence. So particularly whenever we are just understanding, extracting information, all the all the things we extract, that will be just understand according to the context, actually according to the context of the sentence it has been used in the sentence and paragraph. Now we can also leverage it to the extract meaningful information from our text itself. Now let's consider NLTK to generate the part of speech tags. Again, in the Python programming language, we need to write for that. We need to install first NLTK library. If it is already installed, so we don't need to do that. So for that, if it is not there, we need to just write pip install NLTK library, right? In the next line, we are going to just download the POS tagger. So for that, we need to import the NLTK. If it is already there, we will start from here. So importing the NLTK library, and in the next line, I am going to download that particular POS tagger data file. So that will be just done by the writing NLTK.download function. In the function, in the small bracket, I will write in the single quotes or double quotes averaged underscore perceptron underscore tagger. So that is a preloaded library POS tagger to use for the just identify the different POS tagger on that. Now I am going to just tokenize that input word. So I will pass the one input word in the form of text variable. So a text variable is equal to, in the single quotes, Barack Obama was the president of the United States of America. That text I have just passed, and in the next line I will write from NLTK.tokenize import word underscore tokenize. So that is used for the just to make the different tokens out of the different text data. Now I will write tokens variable is equal to word underscore tokenize, and in the that function I will pass in the small brackets text. So whatever text I have passed here, that is going to come here, and I will just print the tokens. So printing the tokens, it is going to give the output. The Barack Obama was the president of the United States of America. Each word as a tag. Each word as a tag here. Now in the next slide, I am going to discuss about how it is going to make the different part of speech out of that. So let's see that. So now I want to generate the different POS tags. So for that I will write from nltk.tag, that is again a class, and that is I am going to import POS underscore tag, that is a preloaded we can say class is there. Now I will make a variable POS underscore tags is equal to we cannot write same name, same keyword as whenever we are just declaring a variable. So we need to change that. So here I have changed with the added s here. So POS tags is equal to POS underscore tag, and in bracket with the function I am just passing the tokens. So from here in the earlier slide, tokens will be applied here. Tokens is going to be applied here. That is going to come here, and then I need to just print that POS underscore tags here. This tag here. So now it is going to give the different outputs in the form of POS tags to generate that. So now just see here what is the difference here. So it is going to give it in the square brackets and in small brackets Barack and NNP. That is a noun. Obama again noun. Was, that is going to be identified as a verb. The, that is a determinator. President again noun. Of means that is a preposition. The, that is again delimiter. United again noun, that's a plural noun. States, that is again the noun but plural singular. Of again preposition, and America, that is again the noun. So likewise that we can just identify the different part of speech tags to just generate the POS tags according to each word, and then we can just understand what is the use of this grammatical aspect of this particular word for this sentence actually. So that is the need of this POS tags actually. So how does it work? So that was about today's topic. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.